its types. Okay, type is inertial frame of reference. Frame of reference. Okay, now what is this type of frame of reference? My dear, this term you have heard about it in the school time, okay, which is really inertia. Okay, and what is inertia? It is a property of any matter by which it opposes its change in state. Okay, let this person is standing on the ground and another person is pushing him. Okay, then he will try to oppose his motion and against the applied force. Okay, so that person have property of inertia, and in this inertia property you have learned about net force is always equal to 0 on any body, because in the absence of external force the body will be at rest. Okay, in the simple case we can consider that let a body of mass m is placed on ground level and there is a multiple forces acting on it, let f1 vector, f2 vector and f3 vector. Okay, now if the algebraic sum of these forces is 0, then we say that external force, total external force is always 0. Now we have conclusion that net force equal to 0, then we can write by Newton's second law. By Newton's second law, F equal to ma. Got my point? And m, acceleration is the rate of change of velocity with respect to time t. Okay, now we can put this value in this equation number first, then we have m dv by dt equal to 0. Got my point? Okay, now we have two terms, m and dv by dt is equal to 0. So according to mathematics we have two possible cases, mass may be 0 and second is dv by dt is equal to 0. But we are talking about an object which is at rest, which have property of inertia, then its mass can be 0 practically. So we cannot consider m equal to 0. Okay, so we have to consider dv by dt equal to 0. It means differentiation of velocity with respect to time equal to 0. It means velocity is constant. Velocity is constant. Okay, got my point? Or we can say that acceleration is 0. On this basis we have another definition of inertial frame of reference is that whenever an object moves with constant velocity small v, then that type of motion is studied under the inertial frame of reference. Got my point or not? Please tell me by writing in the chat box. Got my point or not? Yes? Okay. Now, these facts will be used in the chapter number 2 and also in numericals. Okay. Now, we have second type of frame of reference, which is non-inertial frame of reference, which is non-inertial frame of reference. Now, non-inertial is just opposite term of inertial. It means the motion in which velocity of the body, velocity of a particle is not constant, because it will vary with respect to time t. Okay, got my point? So in the second type we have conclusion that a should not be 0. Okay, it means there is a always acceleration present during the motion. Now we talk about its example. The most famous example is our earth. Our earth. Okay, assume that it is earth and we are on the surface of the earth. Okay, now the person on the earth seems to be earth is at rest. So earth is initial frame of reference for that person which is on the earth surface. But if an observer is in vacuum, say we can see that he may be in satellite. Okay, but for this person which is outside the earth is the part of non-inertial frame of reference, because he will seem to the spinning of the earth. Okay, so there is a must be acceleration of this earth during the revolution in the orbit, during the revolution in the orbit around the sun, around the sun. Now got my point or not? Please respond me in the chat box. Okay, now second thing is you should be take care that in the first type Newton's first law and Newton's second law is are always valid. It means Newton's first law means law of inertia and Newton's second law means law of momentum, that is external force equal to dp upon me dt, and it is the rate of change of momentum with respect to time t, and it is always equal to the ma. Okay, now this both laws are valid in the initial frame of reference, but notice that these laws are not valid in the non-inertial frame of reference. In this type of frame of reference, only Newton's third law is valid, is valid, and you will study about it in further higher level in the post graduation courses. In the BSc courses you will study only about the initial frame of reference. Got my point or not? Please reply. Got my point about these facts? What happened? Board is clear or not? Some noise is coming from your side. No, it is background noise. No, it is clear or not? Now voice is clear or not? You got this point or not? Okay. Now, the first important topic of this chapter is Galilean transformation, which is a very important topic. And why it is important, I tell you. Assume that in a room, there is a physical process takes place, maybe like collision, maybe like revolution of fan, ceiling fan, maybe of the uh, playing of the children's, maybe any process. Let we take example of collision, which is very famous. Let we have two mass particles, that is m1 and second is m2. Okay, now these particles collides, and collision is the basic property of the phenomena, any phenomena. Okay, now during this collision we have some velocity, kinetic energy, kinetic energy. Okay, or maybe other physical quantities can be studied. Let's assume a person is inside the room. Let's assume that a person is inside the room and watching this phenomena, is seeing this phenomena of the collision. Okay, now, and other person is outside the room, and other person is outside the room, and he is also watching that phenomena of collision. Got my point or not? We are talking about the two observers. First is inside the room and second is outside the room. Got my point or not? Yes. Okay, done. Now, focus that for this observer, this phenomena has some particular values of these physical quantities like momentum, velocity, kinetic energy in his system. In his system means in his frame of reference, which is also known as 3D space. 3D space, like it is on the axis X, on the axis Y, and on the axis Z, and origin O. Now, and other person who is watching this phenomena of collision from outside have, he must be have these physical quantities in his frame of reference, which is known as x dash, y dash, and z dash. I mean to say, you can consider that every physical phenomena have some set of coordinates like x, comma y, comma z in the 3D geometry you have studied in the mathematics. And these coordinates are for this observer, which is inside the room, and the person who is outside the room have the coordinate system will be x dash, y dash, and z dash. Okay, that corresponding to that same type of physical quantities, momentum, velocity, and kinetic energy. Got my point or not? Got my point or not? Please reply. Okay. Now, in the world, first scientist was Galilean, who gave the relationship between these type of coordinate system between system S and between system S dash for the various physical quantities like kinetic energy, velocity, and momentum. I mean to say, a scientist Galilean gave relationship between these sets of coordinates of two systems named as system S and system S dash, which are two frame of references x, y, z and x dash, y dash, z dash for the same physical quantities which are related to the collision phenomena. Got my point or not? Yes. Okay. Now, on this basis, we can define Galilean transformation definition. Okay. Now you can write in your class copy. Galilean transformation is the second topic of this chapter, and it's defined as Galilean gave some relationship, some relationship between two frame of references. I am writing it shortly. Two frame of references for S, comma S dash. Okay. Sorry, S, comma S dash for various physical quantity. For various physical quantities like position vector like position, velocity, acceleration, force, etc., etc. Many physical quantities are there. Got my point or not? Tell me. Hitakshi, got my point or not? Is there any problem in the definition? You are free to say me. Okay. Should we forward? Okay. Right. Good. Now, it's the definition, and we have some cases for the relationship between the position vector and velocity and acceleration and force also. We have four physical quantities: position vector, velocity, and acceleration and force. Okay. Now, case test. Now, case test where frame of references S, and dash are both at rest. Both systems are at rest. It means okay. Now it is okay or not? It is okay. Sound is clear to you? Okay. We have some three. No. Not clear. Now tell me, this one is good or not? Now it is okay. Okay, thank you. I want to say that we have some cases in which first case is when both frame of references are at rest. It means we have two observer. First is in the frame of reference S. This 3D system is known as system S, and the observer is at present at origin. Okay, now, and we have a second observer which is in other frame of reference, which is named as system S dash. It is system S, and it is system S dash, and another observer is at origin O dash. Got my point or not? And both the observer are watching the same phenomena. Let any phenomena takes place at point P. Any phenomena is taking place at point P. Okay, and the position of that physical phenomena have position vector R vector with respect to first observer, and this phenomena has a position vector with respect to second observer, which is named as R dash vector. Got my point? Got my point or not? Okay, now, and both observer are at rest, so the distance between the position between both observer is represented by r vector naught. R vector naught. Okay, this distance is constant because both observer are at rest, and the coordinate system of the any process which is at point P is x y z, and second is x dash y dash and z dash corresponding to second observer. Got my point about that? Got my point or not? Okay, done. Now you can see we have a triangle which is formed between the both observer named as O dash O and P. So we can apply the triangle law in this triangle. In triangle in triangle O dash P. In triangle O dash P, we can apply triangle law. Now these sides are consecutive and in the same order. Okay, and the opposite side is r dash vector. So we can write r dash vector will be the sum of r naught vector plus r vector. Okay, it is the first equation for the case first, and this equation shows the relationship between two position vectors which are from different frame of reference s and sz. Got my point or not? Yes, okay. You can take a screenshot first, please, because I have short board and I will continue for the case second. So please take the screenshot and you can watch this video again on the YouTube after live session if you miss some points, because after processing of live class this video will be smoothly running without interruption. Okay, have you took screenshot or not? Have you took screenshot? Okay, thank you. Now case second. Case second is any one frame of reference or any one system is moving with constant velocity, because we are talking about the initial frame of reference. Okay, so let we assume that system S is at rest and system S dash is moving with constant velocity to V. I write shortly with V. You can write with constant velocity V. Now, in this case, you can consider that this whole system is moving with a constant velocity v vector in any direction, maybe along the x dash, maybe along the y dash, and maybe along the z dash. So theoretically we represent that this whole system is moving with constant velocity, which is written by v vector, and please use this velocity in capital letter, because its reason I will explain you during the numericals. So take the symbol capital letter of the velocity. Got my point or not? Got my point or not? Yes, sir. Okay. Now, be practical in this example. If this person is moving continuously with constant velocity v, then the distance between both observer will not constant, will not constant, because this distance varies with time continuously as this person is moving forward. So this distance between the both observer, which was r naught vector, is represented now v vector and t, because the mathematics distance is always equal to the speed into time. So, and another factor, is that the direction of arrow will opposite, because this person is at rest and second person is moving. Okay, so we'll take the position of second person with respect to first person by taking arrow towards the O point to O dash point. Got my point or not about this direction? Because this person is stationary and this person is moving. Got my point or not? Because I have another example for that. Why will we take the direction from the O to O dash? Okay, thank you. Now you can see that now in this case these consecutive sides are in same order in the anti-clockwise manner. So this time this r naught vector will be added in the r dash vector. So this will be r dash vector and it will be the r vector, and second equation of the position vector will be r vector equal to r naught vector plus r dash vector, and this equation can be written as also like that, like that r vector equal to v vector into my t plus r dash vector. It is the third equation, and it is a third relationship between both frame of references s and s dash. Got my point or not about that? Got my point or not about this equation, which is very important for the numerical? Okay, now Hitakshi, notice that we have two equations in both cases. First was r dash vector equal to r naught vector plus r vector, and second equation is that, and third equation is that r vector equal to v vector t plus r dash vector. There is a big difference between these two equations, because this equation is known as time independent time independent equation, because there is no term of time. But this equation is also relation between two systems, but this equation is time dependent, because here time t is available and time is increasing. Okay, now this equation is known as time dependent position relationship between two frame of reference. Okay, got my point or not? Anjali, thank you, but it is not 12th class, it is BSc class. Akshita, tell me, got my point or not? It is time dependent and it is time independent. Okay, Hitachi. Now, in the numerical, when you will solve the numericals from the textbook, which is CBH College Book House of the fifth subject, you will found that this equation is used in the numerical like that: x dash equal to x minus vxt, sorry, v vector t, and y dash equal to y minus vt and z dash equal to z minus vt. Okay, now in this, Rajkumar, no, it is not 11th class. Hitakshi, focus that this equation can be written as these equations, because from this equation we have main equation, fundamental equation, that is r vector minus v vector into t. Okay, but in numericals, during the one dimensional motion, you will find out coordinate system between x y z and x dash y dash and z dash. Okay, got my point or not, Hitakshi? Because this equation represent the relationship between the coordinate system between two frame of references s and s dash. Hitakshi, do you have book of this paper or not? You need some examples, some numericals for the practicing these equations. Are you listening me? Yes, sir. Okay, Takshi. You should solve the numericals on the basis of Galilean transformation, and in any numerical you find difficulty, then you can ask me after the 8:30 p.m. Okay, on the maybe in live session, and maybe in the after live session after 9:30 p.m. Okay, so please solve all the numericals you found on the Galilean transformation, and notice that some numericals are of very high level because their link is from the chapter number 3. So don't be nervous during the solving of the numericals. Okay, and we will start the we will continue this chapter, okay, for the rotational frame of reference, because in previous two cases you have studied that when both frame of reference are at rest, and second one is at rest and second is moving. But in the third case we will talking about the rotational frame of reference, because in which one frame of reference will be at rest and second frame of reference will be in rotating state. Okay, now got my point or not, Hitakshi? What happened? Okay, Hitakshi, now this lecture is over for this topic. Okay, hello, are you listening me? Okay, then Hitakshi, see you tomorrow. Okay.